Welcome students. Welcome again to my another new lecture. I am Muhammad Tanvir Ahmed, lecturer at Department of Civil Engineering, World University of Bangladesh. In today's lecture, we will discuss about infiltration, factors affecting infiltration, infiltration rate and capacity, infiltration indices. And there are two infiltration indices, which are phi index and W index. And finally, we will practice some examples that how to calculate the infiltration indices. First, we will introduce about infiltration. Infiltration occurs during rainfall. So, it is directly related to hydrological cycle. According to the hydrological cycle, water is constantly evaporated from the earth due to heat energy from sun and is precipitated back on the earth when it cools, mainly in the form of rainfall. One part of this rainfall sinks into the ground, which forms groundwater reservoir. Generally, infiltration is the main source of groundwater reservoir. The major part flows as runoff in the form of rivers, which finally reaches to the ocean, and the rest is lost in evaporation, which occurs by heat from sun, and transpiration, that means evaporation from plant foliage, and others as infiltration, which is generally added to the groundwater table. Now in short, we can say infiltration as the process of water entering the surface strata of the soil and moves downward towards the water table is known as infiltration. In another way, we can say the process of downward movement of water into the soil and finally reaches to the groundwater table is called infiltration. Figure shows how precipitation enters into the groundwater table. Here, water is entering into the soil by downward movement and finally reaches to the groundwater table. Factors affecting infiltration. The main factors that influence the infiltration are the soil type, such as texture, structure, hydrodynamic characteristics. For example, we can say the infiltration rate is greater in sandy soil than in clay soil. Then, the soil coverage, for example, vegetation. If there exists vegetation in ground, the infiltration rate will be decreased. Then, the slope of the ground. The more the slope, the more will be the runoff velocity of water, and as a result, infiltration will be decreased. Density of fluid. The dense fluid will infiltrate slowly than the lighter one. The flow supply, for example, rain intensity, irrigation flow, etc. If the flow supply increases, the rate of the infiltration will also be increased. The last one is the initial conditions of soil humidity. If the soil is wet, the infiltration will be decreased. Otherwise, it will be increased. Infiltration capacity. The maximum rate at which a soil in a given condition is capable of absorbing water is called its infiltration capacity, which is denoted by F. In another way, we can say the maximum rate at which water can enter into the soil is called infiltration capacity. Infiltration rate. The prevailing rate at which the water will enter the given soil at any given time is known as infiltration rate. In other way, we can say it is the effective rate into which water is entering into the soil in a given time. Infiltration indices. The average rate of infiltration is called infiltration index, and the plural form of index is indices. There are two types of indices are in common use, which are phi index and W index. The plural form of these two index is called infiltration indices. Phi index. The phi index is the average rainfall above which the rainfall volume is equal to the runoff volume. That means the phi index indicates the infiltration, and above infiltration the rest volume is ready to run off. The initial loss is also called as infiltration, which is due to the heat absorption in wind and in soil. The phi value is found by treating it as a constant infiltration capacity. So we can say phi index will be the average infiltration rate. If the rainfall intensity is less than phi, then the infiltration rate is equal to the rainfall intensity. The water that comes to the earth, if infiltrate completely, we can say infiltration rate is equal to the rainfall intensity. And if the rainfall intensity is larger than phi, the difference between rainfall and infiltration in an interval of time represents the runoff volume. The amounts of rainfall in excess of the index is called rainfall excess. Rainfall excess means runoff, and the amount of excess or extra water then the infiltration index will start runoff. From the above discussion we can say phi index equal to infiltration divided by time. That means phi index is the average infiltration. W index. W index is the same as the phi index, but it is the refined form of phi index. In phi index, no initial losses is considered, which is considered in W index. So, in an attempt to refine the phi index, the initial losses are separated from the total abstraction and an average value of infiltration rate called W index, and is defined as W index equal to P minus R minus IA divided by TE. Here P equal to precipitation, R equal to total storm runoff, and when we subtract total storm runoff from total precipitation, we will get infiltration. So we can write this two term P minus R as infiltration. So from phi index we have seen that phi index equal to infiltration divided by time. So when we subtract initial losses from this infiltration, we will get W index, and IA is the initial losses, T is the time duration, that means total time, and W is the average rate of infiltration, that means W index. Example, let's read the question. A storm with 10 cm precipitation produced a direct runoff of 5.8 cm. So the value of precipitation is 10 cm and direct runoff is 5.8 cm. The time distribution of the storm as given below. This is the time distribution of the storm. We can see that the duration of the storm is 8 hours with 1 hour interval. And this is the incremental rainfall in centimeter, and if we sum this total rainfall, we will get the total precipitation, that is 10 centimeter. We have to calculate the phi index of the storm and the total rainfall excess, that means the total runoff. Let's start to solve the problem. Here given total precipitation equal to 10 centimeter, which is stated in this question, and also we can get this from this table. A direct runoff equal to 5.8 centimeter, which is also stated here. If we subtract this direct runoff 5.8 centimeter from total precipitation 10 centimeter, we will get infiltration. So total infiltration equal to total precipitation minus total runoff. And finally we will get total infiltration equal to 4.2 centimeter. Here the time duration is 8 hours. So the time of rainfall excess is 8 hours. And this is our first trial, and we have to take second or third trial if necessary. We know phi index equal to total infiltration divided by time. Here total infiltration equal to 4.2 centimeter and time equal to 8 hours, which is taken from the last slide. So finally we get phi index equal to 0.522 centimeter per hour. The rainfall at first hour and 8 hour from the given table are 0.4 and 0.5 centimeter respectively. Here the rainfall for first hour is 0.4 centimeter and for 8 hour is 0.5 centimeter. And this two value will be ineffective as the magnitude is less than 0.522 centimeter. So the rainfall value, which will be less than the phi index, will be ineffective. Here only these two value 0.4 and 0.5 centimeter will be ineffective, as only this two value is less than the value of phi index. As the rainfall value of 0.4 centimeter and 0.5 centimeter will be ineffective, so we will have to subtract these two value from total precipitation, that means from 10 centimeter. And if we also subtract the direct runoff from this value, that means 5.8 centimeter from this value, we will get the infiltration. So here infiltration equal to 10 centimeter, that means total precipitation minus 2 ineffective precipitation, which are 0.4 and 0.5 centimeter, minus total direct runoff, that is 5.8 centimeter. So finally infiltration stands 3.3 centimeter, and the new time duration is 6 hours, as the time of first hour and 8 hours, these 2 hours has ineffective, so our new time will be 8 minus 2, that is 6 hours. So our new rainfall starts from, we can say, from 2 hours, and it starts from 7 hours. Now we know phi index equal to infiltration divided by time, and here infiltration equal to 3.3 centimeter and time equal to 6 hour. And finally we get the value of phi index as 0.55 centimeter per hour. And if we check this phi value with the rainfall value, we can see all value start from 2 hours and ends from 7th hours are greater than this 0.55 centimeter. So this is okay, and our final phi value is 0.55 centimeter. Now estimation of rainfall excess. Phi index is the average infiltration, and if we subtract this phi value from each hour rainfall value, we will get rainfall excess, that means runoff value. Here, these are the rainfall value and this is the phi value. We will subtract this phi value from all this rainfall value. So the value of first hour will be 0 as this is ineffective. Then we will subtract 0.55 from this second hour rainfall. So the second hour rainfall will be 0.9 minus 0.55 centimeter, that is 0.35 centimeter. Similarly, we will subtract phi value 0.55 centimeter from this third hour rainfall. So the third hour rainfall stands 0.95 centimeter. Similarly, we have done the same calculation for 4, 5, 6 and 7th hour. And if we sum all these individual hour rainfall or individual hour rainfall excess, we will get the total rainfall excess, which is 5.8 centimeter. This is the another example. Let's read the question. The rainfalls on 5 successive days on a catchment were 2, 6, 9, 5 and 3 centimeter. If the phi index for the storm can be assumed as 3 centimeter per day, find the total surface runoff. So these 5 values are the rainfall value for the 5 successive days. That means this 2 centimeter is the rainfall value for first day, 6 centimeter is the rainfall value for second day, and so on. The phi index is assumed as 3 centimeter per day and we have to calculate the total surface runoff. Let's start to solve the question. Here the time is stated as 5 successive day. So the time in day is 1 to 5 and the rainfall for first day is 2 centimeter, second day is 6 centimeter and so on. The value of phi index is 3 centimeter per day. And we know phi index is the infiltration value, and if we subtract this phi value from this rainfall value, we will get the surface runoff. And again we know the smaller value of than the phi index will be ineffective. Here the rainfall value of first day is 2, which is smaller than 3. So this value will be ineffective. Here, as first day value is ineffective, so the rainfall excess or surface runoff for first day is 0. If we subtract this 3 from 2, we will also get a negative value, and in the sense of this, negative value will not be taken or negative value will not be consideration in a calculation. And the second day value is 6 and we will subtract this 3 from this 6 and we will get the rainfall excess or surface runoff is 3 centimeter. Similarly, the third day rainfall is 9 centimeter and we will subtract this phi value from here. Similarly for fourth day and also for fifth day. So these are the rainfall excess or surface runoff for each individual day. And to calculate the total surface runoff, we had to sum this total value. And if we sum all this total value, the total surface runoff stands 11 centimeter. So that is the end of our today's lecture. Thank you everyone.